Hello friends. So continuing with the subject pharmacognosy, we have already started with the topic chemical nature of crude drugs. As I said that there are different classes of chemical constituents and we should know about their occurrence, distribution in nature, their definition, classification, then uh, isolation methods and some important identification test. Now last time we have covered alkalides. In today's lecture we will see glycosides. Now some of the glycoside containing drugs also we have covered. Now glycosides are compounds which upon hydrolysis give rise to one or more sugar component and compound which is a non-sugar component. Sugar component is called glycon and non-sugar component is called a glycon. So these two portions are obtained when these glycosides are hydrolyzed. So they can be hydrolyzed by either acid or any enzyme. Now in a glycosidic compound, a sugar residue is linked to C1 through oxygen and O glycosides, isn't it? Then nitrogen, that is N glycoside, or sulfur moiety, that is S glycoside. So we will see later on the classification of glycosides also, which is based on glycosidic linkage, isn't it? But first, in few slides, we will try to and understand about the glycosides. Now again, other definition we will see that glycosides are non-reducing organic compounds that on hydrolysis with acids or alkalis or enzymes they give sugar part which is called glycon moiety, and it is formed of one or more sugar units, and other part is non-sugar part which is called aglycon part or genin. It is another term which can be applied. Now glycosides are usually non-reducing compounds. On hydrolysis by reagents or enzymes, they give one or more reducing sugars among the product of hydrolysis. So if alcoholic or phenolic compound is there, so O glycosides, sulfur containing compounds S glycoside, nitrogen containing compounds N glycosides and C glycosides, isn't it? Now alpha and beta glycosides sugars exist in isomeric form, either alpha or beta, and both these alpha and beta glycosides are theoretically possible. All natural glycosides are of beta type. Some alpha linkage exists in sucrose, glycogen and starch. Also the glycosides like strophantoside, isn't it, which is present in strophanthus, isn't it? Now this strophantidine, it is linked to strophanthiotriose, isn't it? Or it is also called cymarose, which is beta glucose and alpha glucose. Now, classification of glycosides. One of the classification is based on the glycosidic linkage, isn't it? So first we will see the classification which is according to glycosidic linkage. So according to glycosidic linkage, the classification is given, and we can also say that these are the classes of glycosides according to chemical group of a glycon part involved in the acetyl union. Like one is O glycosides which contain hydroxyl group, S glycosides contain sulfur group, N glycosides they contain nitrogen group, and C glycosides which contain carbon group. Now according to nature of simple sugars component, as we have seen that glycon part is present which is a sugar moiety, isn't it? So sugar moiety is present which is responsible for the solubility, isn't it, and hydrolysis of the drug. So the nature of simple sugar that is present in the glycoside, one is glucosides, the glycon is glucose, galactosides where the glycon is galactose, mannosides where the glycon is mannose, arabinosides where the glycon is arabinose. So this is another, we can say these are some of the important sugar moieties which are present in glycosides. According to number of monosaccharides present in sugar moiety, isn't it? Some examples are given like salicine where one monosaccharide is present, then two monosaccharides are present in gentobiocide and three monosaccharides are present in strophanthiotriose. Now, these glycosides in plants are synthesized and hydrolyzed under influence of some or the other enzymes. So enzymes play important role in their synthesis and hydrolysis. Now they are crystalline or amorphous substances which are soluble in water or alcohol and insoluble in organic solvents like benzene and ether. Chemically, glycosides are considered as sugar ether. In pure state glycosides, mostly they are levorotatory, colorless and bitter in taste. Classification, one of the classification we have seen which is based on glycosidic linkage, isn't it? So that is given in this slide also. Then one classification is based on glycon moiety, isn't it? So this is just repetition in this slide. One classification based on the type of glycon present other classification based on the glycosidic linkage, and accordingly the four classes are there, like O glycosides, N glycosides, S glycosides, and C glycosides. Now, this is another one classification, and which is comparatively more important. This classification is based on the chemical nature of non-sugar moiety. That means a glycon part which is present, and this a glycon part is responsible for pharmacological action, isn't it? Glycon is a sugar part, and that sugar part has got just role in solubility and hydrolysis. But this aglycon part, non-sugar moiety, is more important. So some of the important classes we will see, and this is important classification. One is anthraquinone glycosides, and here anthraquinone moiety is present, isn't it, as a aglycon part. For example, senna. So drug senna we have already covered in laxatives which contain anthraquinone glycosides. Other is cardiac glycosides, where the glycon part is steroid molecule, and cardiotonic drugs we have covered, in which digitalis is the important one example. Then saponin glycosides, where licorice is the drug, glycyrrhiza is the another name. Cyanogenetic glycosides, another class, where wild cherry bark is there. Then isothiocyanate glycosides, where black mustard is the example. Flavonoid glycosides, where example is Rutra graveolens. Coumarin glycosides, where celery fruit. Then LDL glycosides, for example vanilla pods. Phenol glycosides, example salsiu. Steroidal glycosides, then miscellaneous, example is salix species. Lactone glycosides, cantharide. So this is one more important classification of glycosides. Now we will see some of the important properties of glycosides. First, physical properties, like these glycosides are colorless, solid, they may be amorphous or crystalline, they are non-volatile in nature, they give positive reaction with Molish reagent, failing solution, they are water soluble compounds, insoluble in organic solvents, but soluble in chloroform and ether. The glycon moiety is insoluble in non-polar solvents. Most of them have bitter taste. There are some exceptions, like glycyrrhizine, which is present in glycyrrhiza drug, having sweet taste. Glycoside cannot reduce failing solution until they are hydrolyzed. They are believed to facilitate growth and protection of plant. Now, chemical properties. These glycosides, they are odorless, they have lot of sugars, and when more sugars are there, then the solubility pattern also changes of these glycosides in water. Now, these are hydrolyzed by mineral acids in presence of enzymes. They show optical activity, they contain sugars, but still the therapeutic activity is based on a glycan portion. Sugar portion facilitates absorption of glycosides, and this helps it to reach at the site of action. Now, the another part is functions of glycosides, or we can say what is the role of glycosides in plant organism. Now, this helps to convert toxic material to less toxic. Toxic means harmful. So whatever harmful material is there, that becomes less harmful. Here, glycosides play important role in the plant. Then they transfer water insoluble substances by using monosaccharides. Then it acts as a source of energy. So it is acting as a reservoir, storage of sugars. It also stores harmful products such as phenol. It also plays important role in the growth, that is the regulatory function. Some have beautiful colors also, that is pollination process. So these functions that we have discussed, so they can be categorized in three portions, that these glycosides have got regulatory function, protective function and sanitary function, isn't it? So in plants, these three type of functions are played by glycosides: regulatory function, protective function and sanitary function. Now next part in this glycosides is extraction and isolation of glycosides. So how they are separated from the drug, there we will see the techniques, and one important test is also there. Now these have got variable physical and chemical properties, isn't it? So there is no any agreed common general method which can be used for isolation of glycosides. But the solvents that are used may be water, isn't it? And even alcohol can be used. Now, some precautions are very important which are to be followed before extraction, that deactivation of enzymes, maintenance of neutral condition and removal of fats, isn't it? So these three steps are to be followed and maintained for proper extraction of the glycosides from the plant. Now, how they can be separated, that we will see. Because of wide range of physical and chemical properties of these glycosides, there is no any general method which can be used for isolation, but the number of solvents can be used for extraction of glycosides. Now this may be water, methanol, or water and ethanol can be mixed in different proportion, isn't it? And they can be used as a solvent, or purely ethanol also can be used for the extraction of glycosides. Now, precautions that we have already seen which are to be followed, but just again to be revised, that the deactivation of enzymes is very important. So here the drying for 15 to 30 minutes at 100 degree followed by slow drying at low temperature will result in deactivation of enzymes. Then dipping the fresh material into boiling water or boiling alcohol for 10 to 20 minutes also will result in deactivation of enzymes. Then alternatively, the fresh plant material can be boiled with acetone, isn't it? Then carrying out extraction at very low temperature, freeze drying of the plant material before extraction, and carrying the extraction in presence of the compound. Various compounds can be used. Now this is one of the important method which is used by the pharmaceutical companies for extraction of glycosides, and the name of the technique is Stass Otto method. Now here, first of all, the drug is powdered, isn't it? Then this is extracted with alcohol by using Soxhlet apparatus. The reason for using alcohol and heat are alcohol denaturates proteins, hence all enzymes will be deactivated. Solubility of glycosides in alcohol and heat is applied to deactivate enzymes. However, heating should be done in 45 degrees centigrade as most of the glycosides are sensitive to heat. They are thermolabile. Then collect the extract and filter it. Repeat the same procedure for two or more times to get maximum product, and combine all the filtrate. So that is the important, you can say, method of extraction, that is called Stass Otto method. Then we must know the medicinal importance of glycosides. Now we know so many drugs we have covered, glycoside containing drugs, and there are different classes of glycosides, isn't it? So they have got a role in curing most of the diseases also, like cardiac drugs, cardiotonic glycosides, isn't it? For example, digitalis we have covered, squill we have covered in miscellaneous drugs, isn't it? Strophanthus is another example. So this is one of the first medicinal importance of glycoside, that they can be used as cardiotonics. Then laxatives drugs we have covered. So senna, aloe, rhubarb, cascara, isn't this is another important use of glycosides. Then most of the glycosides are used as counter irritants, for example, thioglycosides and their hydrolytic products, isn't it? Then these glycosides can be used as analgesics also, like methyl salicylate, which is a hydrolytic product of Goltherin plant. Then anti-rheumatic So salicin is the example, but we have also seen the drug colchicum, isn't it? Colchicine, which is a anti-rheumatic drug, isn't it? But salicin is a glycoside, and colchicum that we have covered, it is a alkaloid, isn't it? So just to make you understand that glycosides also have got medicinal uses, and these are the some of the important categories of medicinal uses where glycosides play important role. Then some glycosides are claimed to reduce capillary fragility, isn't it? Flavonoid glycosides, then hesperidin and all that. Then they have also got anti-inflammatory action also, like glycyrrhizin that is present in glycyrrhiza has a demulcent action, expectorant, and antispasmodic. Then as a anti-cancer agent also, amygdalin is the example, which is you can say glycoside, isn't it? And it has got role in treatment of cancer. So this is all about the glycosides. I hope you will find this lecture beneficial. If you don't understand any point, so you can ask me, or you can listen the video for twice or thrice, isn't it? Also, try to complete your notes while listening this video. Complete your registers, which will be beneficial for the exams. Thank you.